Alright, in this video I'm going to show you how to solve multi-step equations using what I call the CSI 1 and 2 step. So let me show you what I'm talking about. Alright, so before we do that, I want to review what we learned in the previous video where I taught you how to solve 1 and 2 step equations. So this first equation on the left, x divided by 3, or x over 3 equals 12, is a one-step equation. It's only going to take us one step to solve this. In fact, remember we said the goal whenever we solve equations is to isolate x on one side or get x by itself. And we're going to use two principles to do that. The first one here is whatever you do to one side, add, subtract, multiply, or divide, must be done to the other side. And the second principle we're going to use, is what I call the rule of opposites. So let's go ahead and use these two principles as we try to get x by itself. So if I want to get x by itself in the first equation here, I need to get rid of the 3. So the opposite of dividing by 3 is multiplying by 3. And so we're going to multiply each side by 3. Now on the left side, notice I put that over 1, so we do 3 times the x and 1 times 3, and or you can just cancel the 3's and you're left with x over 1 or just x. When you multiply that side by 3, you got to remember to multiply the other side by 3 in order to keep the equation valid, and we get x equals 36. Now keep in mind, if you actually showed a step in between, you could say 3x over 3, and then that's how you get the x. On the second problem here, we called this a two-step equation because notice if you're trying to get x by itself, you're going to have to get rid of that 2 by dividing, and you're going to have to get rid of the minus 7 by adding 7. So what we discussed last time is you want to add or subtract first when you're solving two-step equations. So let me make that comment down at the bottom here. Always want to add or subtract first on each side before dividing or multiplying on each side. So in this case, let's add 7 to each side. Notice a 7 and a minus 7 is 0, and we're left with just the 2x on the left. 5 and 7 gives us 12 on the right. And at this point, we can see that x would be 6, or you can divide it by 2, either way. All right, so let's move on to multi-step equations. So I said the CSI 1 and 2 step, let's make sure we understand what the C, S, and I stand for. Now in this video, well, let me give you the first one here. C stands for clear fractions. In this video, I'm not going to show you how to clear fractions. I'll do that in the next video. But the next one we will do. S is for simplify. So the first thing we look for is, are there any fractions? Which again, we'll do that later. But assuming there's no fractions and these problems won't have any, we move on and we will try to simplify one or both sides as needed. And then the last step is what I call isolate. That means I want to get x on one side only because sometimes x is on both sides of the equation and we want to get it on one side only. So let's go ahead and do some problems and see how we use CSI. The value of CSI is if you do these three things, then you'll be left with either a one or two-step equation, which by now I hope that you find are easy to do. If not, you want to go back and practice your one and two-step equations. Alright, so let's get started. So here's two problems here. Look on the first one there. Again, no fractions on any of these. We need to simplify though. Notice we've got a 1x and a 3x on the left. We can combine that and get a 4x. And then notice we need to get rid of that. Well, by the way, this is a one-step equation, so simplifying was all we needed to do to get ourselves to a one-step equation. So we need to divide by 4 to get x by itself. We're going to get x equals 1/2. All right, if you want, you can try too and then watch the video. And let me go ahead and show you this one. So it's very similar to what we just did. The 7x and the minus 2x are like terms, so let's combine those. and we get 5x plus 5 equals 40. So again, all we had to do is simplify the left side, and now notice we have a two-step equation. So let's subtract first. We're going to get 5x equals 35, and then we'll need to divide, or you can do that in your head, and you get x equals 7. All right, let's move on. So here's two more that are a little bit harder. Number 3, notice you're going to have to use the distributive property. Now, we did this when we were working with algebraic expressions, and we're going to do it in a very similar, or basically doing the same thing. We're just working with equations now. So let's go ahead and distribute here. 5 times 2t is going to be 10t. 5 times a minus 3 is going to be negative 15. We'll write that as a minus 15. And then on the other side we have 30. So notice we're down to a two-step equation. All we had to do was simplify. We'll add 15 to both sides, and then at that point we need to divide by 10. Now notice I divided the 45 over 10 in the numerator and denominator. I divided them both by 5, and I get 9 halves. Now if you divide it on a calculator and you got 4.5, that is the same. But again, let's not avoid the fractions. There's nothing wrong with writing an answer of 9 halves. All right, on number 4, let's see how you did if you tried that one. So you had to distribute. Again, we're just simplifying here. So we're going to get 6n and a minus 3. And then don't forget the minus 12 is separate. We're not distributing the 3 times the minus 12 because it's not in the parentheses. But we don't want to forget about it. Make sure you bring it down. And notice we still have a little bit more to do on the left to have this thing simplified. A minus 3 and a minus 12 or a negative 15, and we would write that using subtraction. And so we're going to have 6n minus 15 equals 15. Again, in this problem, all we had to do was simplify, and now we have a two-step equation. So we'll add 15 to both sides first, and now we know n is 5, or you can divide each side by 6 if you want, but you'll get 5. All right, let's move on to an equation that's a little bit different. So I want you to look at the left side, 5x minus 3, and notice those aren't like terms, so you cannot simplify the left side. It's already simplified. And the same thing's true on the right. And so simplifying is not an issue here. We certainly don't have fractions. So again, CSI, let me go ahead and write that down here. Again, clearing fractions we'll get to later. We don't have any simplifying to do. But we do need to get x on one side only, so we need to isolate x on one side. That's what our I is for. So the thing is, if in this case we need to get rid of that whole 2x term. So I want to make a comment here. To get rid of a term on one side, add its opposite to each side. So in this case, I want to get rid of the 2x term. So the opposite of a 2x is a minus 2x, and so that's what I'm going to do on each side. I'm going to have a minus 2x, or subtract 2x. So notice on the right side, well, actually, let's do the left side first. 5x and a minus 2x gives you the 3x. You got to combine that minus 2x with the like term, 5x, and then just bring the minus 3 down. On the right side, notice that hold on just a second, these terms add to 0, and you're just left with the 12. So in one step again, just by trying to get x on one side only, we ended up with a two-step equation. So we're going to want to add 3 to both sides. We get 3x equals 15, and we can divide by 3, or you could just do that in your head and you get 5. All right, here's another one you might want to give it a try. Be careful with this one. All right, so let me show you how to solve this. So you could add 3x to both sides, but you could also add 7x to both sides. Usually, I recommend that students don't get rid of a term when it's the only term on that side. So I really don't want to get rid of the minus 3x because then I would have no term on that side. So let's go ahead and add 7x to both sides. We're going to get 12 equals 4x, and then notice we're just going to get 3 here. All right, we're down to our last two problems. Now on this first one, I want you to notice things look complicated. But again, if you remember the CSI thing, whoops, let me change colors here. Again, no fractions to clear. We got some simplifying to do, so that's what we do first. So the thing I like about CSI is it helps me to know what to do. I'm never confused about what I do next. Right now I'm going to start by simplifying. So I'm going to have to distribute on the left. So 3x times 2x is a 6x, and 3 times a minus 7 is negative 21. So we'll write that as minus 21. And then don't forget to bring down the 1. Again, the 1 is not part of the distribution with the 3 there because it's not in the parentheses. On the other side, notice we have our 4x and 9x terms, a minus 9x. Those can be combined to a minus 5x. And again, bring down that 13. So we're not quite there yet. We do have a minus 21 and 1 on the left we can still combine. And so notice now I've simplified everything I could on each side. Now keep in mind that like the 6x and the minus 5x, they're on opposite sides, and so when we talk about simplifying, it's only dealing with one side at a time. So we can't just add a negative 5x and a 6x because they're not on the same side. What we do need to do here now that we've simplified is get x on one side only because it's not currently that way. We need to get rid of that minus 5x. So let's go ahead and add 5x to both sides. We're going to get 11x minus 20 is equal to 13. Notice we now have a two-step equation now that we did CSI. That's why we do it. We'll add 20 to both sides, and you can probably see that that's 3. All right, so one last one to do here. See if you can do this. Now the left side is something similar to what we've done before when we were simplifying expressions. Let's see how you do with this one. All right, so let's see. First of all, we're going to bring down 5x, and we've got a minus in front of parentheses. We know that there's a 1 in front of that parentheses. There's one of those. And so what we're really doing here is, because of that minus 1, we're going to distribute a negative 1. Negative 1 times 3x is negative 3x, so we'll write that using subtraction. And negative 1 times negative 2 is a positive 2. So we'll write that as addition, or using addition. On the other side, don't forget to bring down the minus 4. Now if you're thinking in terms of CSI, again, no fractions to clear. Simplify, we're not quite done yet. We've got a couple like terms on the left. We're going to end up with 2x plus 2 equals negative 4. Notice in this problem, I don't have to worry about isolating x on one side. It's only on one side. We're down to a two-step equation, so we just need to knock this out by adding or subtracting first. We'll need to subtract 2 on both sides. Again, our goal is to get x by itself, so I want to get rid of that 2 first. And then I've got to get rid of the other 2 by doing division. Or again, you could do this one in your head, and you can see that x is negative 3. All right, and so those are some examples of how we solve multi-step equations.